Dr. Sunayana, namaste.
Namaste, how are you?
Namaste. Thank you very much. You are
Of
accepting my
course,
request and joined.
of course, of course.
So, as I know, you are so much busy and doing many qualitative work, not like us, it's only quantitative. Some,
No. Everyone is busy, but yeah.
yes, that I know. So, thank you very much. I think let me introduce you, then we can start without
Sure,
wasting our time.
sure.
So, good afternoon, one and all present here. So, here Dr. Sunanya is here with us. She is a principal researcher at Microsoft Research India, I think in Bangalore, where she leads research at the intersection of multilingual and multicultural natural language processing, large language model, and this LLM evaluation and responsible AI. Her research focuses on making AI systems more inclusive, equitable, and effective across diverse languages, culture, and communities worldwide. She has spearheaded influential initiatives such as Megaverse, and Pariksha, large-scale multilingual evaluation framework for generative AI and language models. Dr. Sunena earned her MS and PhD from Cunningham Mellon University. Her doctoral research focused on the speech technology for low resource languages. That's why I have requested her to at least give a talk. Her work also has published in leading AI NLP venues like your ACL, EMNLP, NNSCL, Interspeech. She is widely recognized for advancing research on multilingual AI, code switching languages, this code switching and language technology for under-resourced languages, mainly like our Odia and other low-resource languages. So our current mission is ensure that AI models are evaluated not only accuracy but also fairness, cultural relevance, safety, inclusive across the world, linguistic and social diversity. And so thank you, ma'am. Ma'am, session is now yours. I think you can start the session.
Sure.
Yeah.
Thank you so much for the kind introduction and also the invitation to come here. Very excited to share some of the work that we've been doing. Hope my slides are visible now.
Yes,
Yeah.
ma'am.
Okay, great. So I'll spend some time just walking through some of the work that we've been doing in evaluation. So our main focus, as Dr. Dash said, is in trying to ensure that evaluation happens not just for English and not just for the Western sort of context, but also for many of the other contexts where AI is going to have a big impact, right? And so we really believe that it all starts by evaluating well. Knowing whether something works or not is the first step to improving it for everyone, right? And so that's the philosophy behind this stream of work. And so I'll try to finish speaking in less than an hour so that we have time for questions and discussion. So I'm happy to take questions at the end of the talk if you have any. All right, so let's jump in. So I'll start by motivating actually, why I think that evaluation is so critical, especially today. And we'll start by looking at this particular chart, which comes from the Microsoft AI diffusion report that was put out earlier this year. There have been many such reports from different organizations. So Anthropic has come up with one, OpenAI has come up with one, and I'm sure others also have similar looking maps of the world. And here, essentially, what you're seeing is that there are some regions of the world where more than 40% of the population, so that is the dark blue ones, are the ones where AI has, diffused or AI has been adopted more. Whereas some other regions of the world where the diffusion is very low or where the adoption is very low. And of course, there are multiple factors behind whether AI is being used or not. But the point here is that it is uneven, right? It is not being spread equally across the entire world, and there are several factors that contribute to this sort of unevenness of diffusion. Okay. So what are the different reasons why AI adoption varies, right? And if you look at the global south, which is essentially, looking at the low and middle income sort of countries, then there are several gaps that exist in these countries, including our own, which lead to which are basically barriers to AI adoption, right? One, of course, is infrastructure, where we may not have electricity, we may not have connectivity, etc., for many of these solutions to work for us. Second, which is the thing that I work on, and I think the focus of this series also is on language. Low resource languages, typically models don't do very well on them because of various reasons. So that is also one reason why diffusion may be low. Economic reasons, so some of the AI solutions may be too costly for many of the countries or people in the countries to adopt. Trust and governance as well. The way that AI is governed differs from region to region. Some are more strict, some are less strict, some have regulations, some don't, etc. So that also causes differences in adoption. Skills as well, like whether people have the skills to use this AI or not in these regions, also that also varies significantly, and that also may lead to different amounts of adoptions, right? So, and there are many cross-cutting structural issues across these also that contribute to this issue. But the one that we are going to focus on is the language and representation piece in our work, because that is the work that we do, where we feel that poor quality models for certain languages and regions will lead to a barrier in adopting these, right? So if people are trying to use Gen AI models, but they don't work very well for their own languages, then they will probably not use AI, or when they are using AI, they will be disproportionately harmed by wrong information or poor quality output, etc. And so that will create barriers. And so if you look at some of the examples of some real world statistics, right? So although we are doing very well in terms of new language models, sovereign models, etc. in India, if you look at some of the stats, so this was a particular study that was created on some real world speech recognition, where they found that there's a word error rate, which is a common metric for speech, of 16% for Hindi, which is okay, which is still usable. But for ODR, the best word error rate is 35% for this particular system in this study, right? And 35% is essentially not usable, which means that that particular intervention is not going to be used in this region, right? Same thing with safety as well. So it's not just about accuracy, but it's also about other metrics that we care about. So this could be seen as fairness, bias. It could even be harmful outputs. It could be toxicity. It could be hate speech. It could be safety, as in threats to people's own personal safety. So self harm, suicide, things like that. The model is not able to handle those kinds of inputs and outputs. So this entire field comes under sort of the bucket of safety. But in this case, there was some study that was done where they found that 43% of the responses basically were not caught by the model in Tamil versus 2% for English, right? So there is a big gap, not only in terms of accuracy of these models, but also of the safety of these models. So either they don't get deployed, or they, even if they get deployed, they cause harm for some populations, right? So it's very clear that there are significant barriers to adoption, and we, of course, it's not that we want adoption at the cost of everything else, but if AI is going to make everybody much more productive, if it's going to touch every aspect of our life, then we want to make sure that the diffusion of that is as even as possible across the world. And so, what are the factors that actually contribute to the gap between, say, English, which is a high resource language, or a handful of high resource languages? Typically, we think of English, Chinese, Spanish, French, German, Italian, Japanese, etc. Those are typically thought of as the high resource languages, and then we have a very long tail of low resource languages, or mid resource language, and then low resource language, right? And so, what are the gaps that really cause this what are the factors that cause this gap in performance, whether it is in terms of accuracy or whether it's in terms of safety, between these high resource languages and the low resource languages? And of course, the very first one that everybody talks about, very rightly so, it's a very major gap, is the data gap, right? So uh, LLMs would essentially scrape the entire web in order to get pre-training data. There are other data sources as well, data sets, etc., which have been predominantly created for English. The data on the web is also predominantly in English and a few other high resource languages. People who are not represented on the internet, their data does not go, their language does not go on the internet. So their data does not go into the LLMs as well, right? And so this is, of course, a big gap that exists. And there have been many really great efforts, of course, from our own country, like there's AI for Bharat, which, now also we have Sarvam as well. But also other regions of the world have been addressing these through large scale consortia. So there's a Sea Lion project in Southeast Asia for Southeast Asian languages. There's, of course, Masakhane, which is a grassroots effort in Africa as well to specifically address the data gap. And we have also done some work in this in the last few years, in which we have contributed data sets, not just for training, but also for other kinds of things like responsible AI guardrails and so on. So I'll just mention the Updesh one, which we released last year, which is synthetic data for doing post training. So this is for the fine tuning phase, and it is available for 13 Indian languages. So this is not natural data, it is synthetic data, but it is in a format that can be used for post training. And in fact, this has now more than 50,000 downloads on Hugging Face. So it has become quite a popular data set. So you can check that out if you're trying to take any small model and then fine tune it for Indian languages. You can try and see if this improves matters or not. So this is actually, we are presenting this at ACL next month as well, the Updesh data set. The next gap is, of course, yes, we don't have enough data in most of these languages, that is there, but it's not just about data. Right? There are other things also that lead to this kind of gap, although data does matter a lot. So the second kind of gap is the modeling gap. So a lot of the model decisions, including what training data to use, but also what kinds of architectures to use, etc., they're extremely English centric, or they're created for English first, and then we think about, okay, now let us also make this work for different languages, and then we add in the different language data, and we just assume that that's the way to go, right? And so what we have found is that, there can be, we can do better than that. We can actually go in from the beginning itself, looking at a multilingual view, where we know that we are going to have this model that will work on multiple languages. So one of the ways to do that is to use better tokenizers, for example, for languages other than English. So one of the, I think now it is well known, and that the way that the LLM tokenizes different languages is very different. So the way it breaks down words in different languages is different. And in fact, the same information may cost fewer tokens in English compared to, say, Odia, right? And so you are basically, if you're paying per token, then you're actually going to pay more to transmit the same semantic information in Odia compared to English. And this is because of the way that the tokenizer works, which is more inefficient for low resource languages compared to high resource. And so if you're creating a multilingual model, you may want to actually take these kinds of things into account from the beginning. We have also done some work on incorporating multilingual data in post training. How can you do that better to get better results, etc. Some other work that we've done in active forgetting as well. In the pre-training stage, how can you make the model be better at doing multilingual later on, etc. And some prompting variations also to get the best out of the model by doing prompting in a way that the multilingual performance will increase. So there are some interventions that we can make even at the modeling stage, although those are a little more difficult to do, because essentially everybody follows the same modeling paradigm now to create these models with a few variations here and there. And this, especially pre-training and all that, is really done only by a few players, right? In fine tuning we can do a lot, like there are a lot of sort of many of these parameter efficient fine tuning methods, and you can do a lot of innovation there, but the pre-training part is a little harder to do anything in. And then the final gap is the evaluation gap. And this is the work that I will be speaking about going forward, where we've been working on evaluation now for around 6 or 7 years. And what we found when we started was that a lot of models were being made available without ever evaluating them on the languages that the model was supporting, right? So suppose the model claims that it works on 30 languages, right, of the world, but then when we look at the evaluation, we find that it is actually evaluated only on 10 languages or 5 languages. So on what basis are we saying that we are supporting those 30 languages? The basis is that the training data has those 30 languages, right? But that's not really enough to claim that something actually works for all those languages just because the training data contains those languages, right? And so that is why we really started working on this problem of making sure that we are actually evaluating properly on different languages. And so here we've done a lot of work over the last 6, 7 years. So you can see the list here, but I'll go through some of these projects in a little more, and I'll also show you like what the evolution has been of the evaluation journey, because I think that also sort of mimics how the field has been going as well, how the field has matured as well. So a lot of different data sets, techniques, etc., that we have explored in trying to improve the state of multilingual, multicultural evaluation, which I'll talk about next. So just want to, point out one more thing that happened earlier this year. So many of you may be aware of this, AI Impact Summit that happened in February in Delhi, where people from all over the world gathered. This was done by the Indian government, and the Prime Minister gave the welcome sort of address for this. And this picture shows all the frontier model developer CEOs and other leaders. So Sam Altman is there, Dario is there, Sundar Pichai is there, and so on. From Microsoft, we have our president, Brad Smith, as well, plus the sovereign model developers also. And the reason that they're on this stage is actually that all of them signed off on these commitments to do multilingual evaluations. So everybody recognizes that evaluation is a very important part of the model building cycle right now, where sometimes actually evaluation is used directly in model building as well as signals during, say, RL and so on. And if we do it only on English and only from an English centric point of view, then there is a chance that the model training will be completely drifted towards only that, right? And so we need to ensure that we do this evaluation across different languages in different contexts, cultural contexts, and so on. And so all of the frontier model developers have actually signed this commitment during the AI Impact Summit, where they have all said that their organizations will be doing multilingual evaluations going forward. And so my colleague Kalika Bali was the chair of this particular group of the Frontier Model Commitment Group, and because of her work and the other work, the others in that group, this commitment actually came to being. And I think this is a really good step in the right direction, because now we will actually have many model builders doing multilingual evaluations, not just restricted to one or two, and we will get a better picture of how well these models are doing across different languages and contexts. So just wanted to show this to show that this is top of mind for many people now. It's not just an academic exercise, but it is something that people are actually going to be accountable for, given that everybody has signed this commitment. And we should be seeing much more momentum on multilingual evaluations thanks to this particular commitment. All right. So let's go into what AI evaluation should actually look like, and what are the different kinds of evaluation that we should be doing if we want to look at it from a very holistic viewpoint. So there is a framework that has been proposed by Agency Fund, which was developed with some other collaborators, including Center for CGD as well. And they came up with this 4-level framework, which is basically saying that if you want to, if you have an intervention, right? So suppose you have a health bot or an agriculture bot, or you have a some education bot or something like that, that you have, you have basically made it available to a population, and your goal is to, suppose we go with the health example, right? Your goal is to decrease the number of maternal health, increase maternal mortality, for example, right? That's the goal. And you have this AI intervention, you have a bot which talks to the mothers and gives them advice or something, and you want to now see whether it is working as intended or not. So they have proposed this 4-level framework, where the first level is to just look at the model itself, the model behind the AI intervention, and to do the evaluation on that model. So that is basically the kind of benchmarks that we talk about. So MMLU and all of those other benchmarks. They're looking at the inputs and outputs to the model and then trying to do evaluation. The second level of evaluation would be the product evaluation, where you not only look at the model in isolation, but you look at the entire system. So there may be many things that are wrapped around the model. There may be agents, there may be like guardrails, there may be other non-AI kind of things also that are wrappers around the AI system. And that is the thing that is interacting with the user. And then you look at how different product metrics are moving, right? So are people using the system or not? Are they dropping off after using it once? How much time are they spending, engagement, and so on? Those are the traditional sort of product evaluation metrics. So that will give you a signal of how well the entire system is working as a whole. The third level of evaluation is the user evaluation. So this is typically what you would think of when you think of user studies or people who do human computer interaction. They will go and interview people who are using different technologies. They may run focus groups. They will go and see in the field, how the intervention is working. So for example, if we have a health bot, right, and the bot itself works beautifully, but then at the end of the day, the bot is assuming that a woman has access to a phone the whole day, right? Whereas if you actually go into the villages and see, the mother may not have access to the phone during the day. They may only get it in the night when their husband comes back from work or something, right? So those are the kinds of things that you would only see those in the field studies that you do, and those will give signals that model evaluation and product evaluation will never tell you, right? You cannot anticipate many of these things without actually going and seeing how people are using these kinds of systems, whether their behavior is changing or not because of these interventions and so on. So that comes under the third level of user evaluation. And finally, the final level is the impact evaluation. So that is really looking at whether outcomes are changing or not because of the intervention that we are making, right? So our goal is to finally to change some health outcomes, right? To increase the survival rate of mothers, to those, to the mortality rates and so on, right? So is that actually happening or not? So that is done typically by researchers who look into long-term outcome evaluation, impact evaluation. So this is typically in randomized controlled trials that you would have a control group and a treatment group, and then you would measure whether the intervention is really causing change in outcomes or not, right? So all of these are essential for us to actually be able to claim that a bot has managed to make a meaningful change, right? Without any of these levels, it is actually an incomplete picture, because just doing a model level evaluation is not enough, because you don't know how it is actually going to work in the real world. And then even if you know how it will work in the real world for a short term, you need to have longer term evaluations as well, which is the impact evaluation, which will see whether it has the intended impact on the final outcome that we are trying to change, especially in the more social impact kind of situations. But this also applies to very much like product side evaluations as well, because ultimately even in products we are trying to get the users or customers to actually use these and have some improvements on a longer term for their own productivity or for their well-being or whatever it is that the product is trying to solve for, right? So this is a very holistic framework. And right now I would say that the field is doing a lot of model evaluation. So all of the evaluation we hear about is benchmark, 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 right? Like we build this benchmark in this language, we build the math benchmark, we build coding benchmark, etc. Impact evaluation is done by a completely different research community, which looks at RCTs and so on. I don't think the AI community knows a lot about that kind of work, although I think it is very, very relevant. And for the rest of the two, it's very less. The product and the user level, I think we are still not doing a lot of, there's not a lot of focus on that. And so those are some gaps that we see. And I will try to talk about a little bit about how we are trying to extend the model evaluation itself to try and bring in some of the aspects of real world users and so on, in order to close that gap a little bit in some of the work that I talk about. So just to summarize, like why is doing evaluation very important? So evaluations tell us whether the interventions that we are doing, right? Whether it is building a bot or whether it is, building a classifier, whatever it is that we are trying to do and put in the real world, right? Whether those are actually producing the outcomes that we intend. And this is very critical because AI is evolving so rapidly, and it also interacts with society in such complex ways. And it is really sort of touching all aspects of our lives, right? Whether it is our work, whether it's our learning, whether it is our social life, whether it is our health, all of those things are being influenced by AI, right? And so it's very critical that we understand that well, and evaluation is one lens. Accurate evaluation also helps us prioritize. So obviously we don't have unlimited resources. So with the limited resources that we have, what should we pay most attention to improve in order to make the most, move the needle the most? Um, a lot of the technologies that are developed, or most of them that are developed in the West with a very Western centric point of view. And so, or what we refer to as the global North. And for the technologies that are meant for global south, we really need to make sure that we evaluate these, technologies that typically come from global north to make sure that they actually work in our settings. And just because it works in the Western setting doesn't mean that it will work in all settings, right? Especially in the very heterogeneous settings that are there in countries like ours, where there is so much of diversity in terms of language, culture, ways of being, everything changes within, the matter of few kilometers, right? And so just because it works in one setting doesn't mean that it is actually going to work in all of them. And so we really need to do the evaluation to ensure that it does. And finally, like evaluation creates accountability. And so it helps us distinguish genuine impact from hype. So given that, AI has become so popular and there is so much of money also being spent on AI, there is obviously like a lot of hype and marketing also that goes into it, right? And so if we have good rigorous evaluation, then we can actually distinguish what is working well, what is leading to good outcomes versus what is just simply hype, and then we can again prioritize resources and so on in that direction. Now let us go on to the specific part that I will talk about in more detail, which is the model and the system evaluation that we have been working on. So for now, we will ignore the rest of the pillars in that diagram, the rest of the boxes which are on the user evaluation and the longer term impact evaluation and so on, although we'll come back to it later. So let's just look at the complexities of doing model level evaluations themselves, right? So as we all know, Gen AI models are non-deterministic. They're very difficult to control. You change the prompt a little bit, and the entire output changes, right? And so this is okay if you're. I mean, it's still not okay if you're interacting with it. But if you're trying to evaluate it, right, and each time you prompt the system, it gives you prompt the model, it gives you a different response. That makes it very challenging to do replicable evaluations, right? Which you can compare different versions and so on. As I said, like outputs are highly dependent on prompt wording, also hyperparameters and the exact setup that is there. This makes it very difficult even in the academic research world to compare, like if you have a better model or a system to compare against the previous one, unless you know exactly what the hyperparameter settings were. Many of the open-ended problems that we are trying to solve with, especially with Gen AI today, right? They don't really have a single ground truth or a single correct answer, right? So you can have some gold answers or gold labels, but many of these actually don't have a single ground truth. And so it becomes very difficult then to do on what basis will you do the evaluation? Like what are you going to compare the output with in order to assign some sort of score, right? So that becomes a very big challenge. We don't have good metrics in order to do these evaluations. So the traditional metrics that we use in NLP, like Blue, Rouge, and other word overlap based methods, they don't really work for Gen AI. Again, we don't have a single ground truth. So what would we compare against? And given the richness of Gen AI output, it's very difficult to do this word level overlap kind of metric anymore. So we need new metrics. There are, some other variants of metrics, but all of them fall short in some way or the other. And finally, the systems that we are building with the models are becoming more and more complex, right? So we have not just the regular LLM kind of models, we have reasoning models as well, which have this chains of reasoning. We have agents which can, take the model and then they can perform various actions. So we need to also evaluate those actions as well. They have guardrails on top of systems. We have multiple models in the same, like we have multi-agent systems and so on, all sorts of complex things. And so this just increases the complexity of our evaluation task as well. It's not just taking a simple output and comparing it or scoring it, but sometimes you may have like entire reasoning chains, entire, agentic workflows, etc., that you then need to evaluate for correctness and validity and so on, right? So all of these factors lead to a evaluation deployment gap where we see good results in the lab when we are doing this simple kind of evaluation. We may get very high scores, when we see it. But then when we actually go to deploy a system in the real world, then it fails, right? And this is because of the fact that we don't have the right kind of data in our benchmarks. We don't have the right kind of metrics. We may not have the correct, or the ground truth itself may not be valid over here because there is no single ground truth and so on. And so then in the real world, the performance falls much below the numbers that we would see in the benchmark. And this causes a lot of loss of trust in the users who are actually using these kinds of systems, right? If we put out systems that are not working very well and they are expected to use them, then obviously they will not continue to use them anymore. And so the other problem also is that AI evaluation has become a very hot topic, of course, right? So a lot of people are working on it all over the world. Even in India, people are working on it. But time and again, the validity of AI evaluation keeps getting questioned. So there are many efforts that have been made to do big benchmarks and to do different kinds of agentic evaluations and so on. But again and again, people find that actually these are not really valid. So there's this article that talks about a study from Oxford that looked at 445 benchmarks. They examined 445 different benchmarks, and they found that the benchmarks themselves are not valid. Like they have some issues or the other. Either the data is not correct, the labels are not correct, or the benchmark claims to check for something but does not actually check for that, etc. There's also this interesting report by NIST that shows how AI agents are actually cheating on the evaluations. So AI agents are able to take action, so they can also go and search the web. They can also search the evaluator code that is evaluating them for the correct answer. They can also modify the evaluator code itself. And so they have found that many of these agentic benchmarks that are seen as the sort of like the best standard benchmarks that we should all be using for our agentic evaluations, many of those can be gamed very easily by today's agentic LLMs. There has also been a lot of criticism about benchmarks claiming to be more than what they are, right? So, can a single benchmark really claim that it is capturing a very complex topics such as, say, mathematical reasoning, right? Can a single benchmark actually cover that, right? And so this is a criticism of how a particular single benchmark should be very specific on what it is measuring and not claim a very generic claim. And so this paper basically talks about that. Another very popular way of doing AI evaluation, model evaluation, is to use LLMs themselves to do the evaluations. So I mentioned the challenges with metrics and ground truth and so on. And so to bypass that kind of challenge, what people do is they basically make the LLM itself an evaluator, and they give an instruction to the LLM saying that, can you please rate this from a scale of 1 to 5, and if it is very poor, then rate it 1. If it is very good, then rate it 5. And they'll give some criteria for what good and poor means. And then the LLM will basically do the rating for you, right? So the LLM will take any instruction that you give and give you some response, right? It will never say, no, I can't do this, right? And so then in theory, you can use the LLM to do any kind of evaluation or any kind of metric, any kind of rubric. And so that whole paradigm is called the LLM judge paradigm. So we've done a lot of work in this particular space because LLM judges are used a lot. And there's a lot of controversy about these LLM judges not being valid instruments for doing evaluations as well. There's also a lot of work on how you can cheat on different benchmarks. So a lot of the benchmarks are available on they're available on GitHub, for example. So they're already part of the training data of many of the frontier models. So in that sense, the model has already seen the test data, but you can also do other things in order to artificially boost scores of the model on the particular benchmark. Even if you don't train on the benchmark, there are other ways of doing it as well. So that is what this paper talks about. And then finally, this is a paper that again got a lot of attention last year, which talks about a very popular leaderboard which is used called Chatbot Arena LMSys, where there also they showed that that is also not foolproof. Like you can also game a very democratic benchmark like that as well, if you really want to as well. So that is the this paper. So basically, evaluation even at the model level is still, it's not that that is solved and everybody knows how to do it. There are many attempts, but there are also a lot of they have also been refuted a lot in terms of their validity as well. Yeah. So specifically now, let's look at multilingual and multicultural benchmarks. What makes them very challenging? So there's, of course, evaluation in general, which is very difficult. But when you come to multilingual, multicultural scenarios, there's an added layer of complexity. So there are three main reasons why multilingual evaluation, and when I say multilingual here, I mean multilingual, multicultural, everything in the same bucket. But I'll just use the term multilingual to keep it easy. There are three main challenges that we have classified into, which are coverage, representativeness, and trust. And I'll talk a little bit about what each of these mean. So coverage essentially means the coverage of languages, dialects, cultures, etc. in today's benchmarks, right? So if you see any of the benchmarks, if you look at any of the model reports from any of the leading labs, you will find that there will be one evaluation section where they would have evaluated on a bunch of different benchmarks, right? And suppose they have evaluated on 10 different benchmarks, 9 of those will be in English, and then there will be maybe one benchmark that is evaluating on other languages as well. Typically, it is MMLU Pro or one of those kinds of benchmarks. So that one also will have only 10 languages in it, right? And there are 6,000, 7,000 languages in the world. So we have very limited coverage of the languages in these standard benchmarks that are popularly used, and even less of things like dialects and so on, right? So most of the benchmarks that have multilingual coverage will also have only the dominant dialect. They will not have the other um, dialects, registers, etc. in them. And the multilingual benchmarks that do exist are highly dominated by high resource, Western, rich, industrialized kind of languages and settings compared to the ones that are there in the other places like Global South. The second problem is that whatever multilingual benchmarks are there, those are also not representative of how that particular application is likely to be used in those regions. One of the major challenges that we have been sort of really advocating against is translating benchmarks. So one of the techniques to create a multilingual benchmark is you take the English benchmark and you translate it into 10 languages and you get the benchmark in 10 languages. So it's a very easy way of creating a multilingual benchmark, right? And some people even do the translation automatically with one of the translation providers like Bing or Google Translate or whatever, or even an LLM. And so that is almost like an instantaneous thing, right? You can just put any benchmark in ChatGPT and you will get a translated version out of it in any language that ChatGPT supports, right? But is that really representative of how AI is going to be used in that region, right? Does it have the cultural knowledge that is required for that particular application, right? So think of it as, say, there's a health benchmark that has been created, and it has been created in the US context, right? Now, if you just take that health benchmark and translate it into Hindi and Odia, right? Will that still reflect how people in India and in Orissa and all will actually use the that particular health bot that will be built with that model? No, it won't, right? So it will not cover any cultural aspects. It will not cover even maybe some of the diseases that are more common in these regions compared to the US. It will not cover the way that people talk about their symptoms, the way that they will ask questions and so on. All that is completely different, right? And so the few multilingual benchmarks that exist also, unfortunately, many of them are created in this way that is not reflective, not representative of how these will be actually used in these places. So that's the second thing. This particular one is talking about how having a question that is translated from one language to another is not valid because the answer also depends on which region you're thinking of when you're giving the answer. So there is a different answer from a Persian lens and a different answer from a Greek lens. So even the ground truth here of which is the correct answer also varies based on what the culture is, etc. And finally, the problem is of trust. And trust is essentially, again, on about whether something is valid or not as an evaluation instrument. Sorry. So here we did a study of basically many of these open source models. This was a couple of years ago, and some of the popular multilingual benchmarks that were used at that time. And we were looking at how many of these benchmarks data is already there in these models. So the red cross means that the benchmark data is very likely, it's not guaranteed, but very likely already there in the models that we have listed here. And the green tick mark means that the data is not here, right? And so you can see that for all these, really some of these are very good benchmarks, which have been created with a lot of effort, lot of care, which cover a lot of languages, etc. But unfortunately, because they are available on the web, all the models, when they scrape the web, they also scrape the benchmark and they make it part of the training data. And so the model already knows the benchmark data, it knows the correct answer also, because that is also there in the benchmark data. And so basically, all these good benchmarks, multilingual benchmarks that are there, are all not valid anymore because they have already been seen by the model in the training data, right? So it's like losing the benchmark. As soon as you put it on the web and it is scrapable, the benchmark is gone. It cannot be used anymore as an evaluation instrument because it is not valid anymore. So this is a very big problem, especially for multilingual, multicultural benchmarks, because it takes so much of effort to create a good one which covers many languages, many cultures, etc. We can't keep doing it again and again. So it's a very big, it's a pity to sort of lose the benchmark because we have put it on the web and then it has just been scraped and become part of the training data of all these different models. So now I'll just talk about how we have been sort of approaching evaluation. And as I already showed you, like we've done work in different aspects of evaluation, but I'm just showing this as a timeline to show where we have been going, in what direction we have been going in with our own research in my lab. So we started our evaluation effort in even before 2020 actually, and we created the first code switching benchmark. So code switching is when people use multiple languages in the same sentence or conversation. And we created the first benchmark that tried to measure this holistically, called glucose. That was way back. This was all pre-ChatGPT. And after that, we did some work, even post ChatGPT, in trying to do large scale evaluation, multilingual evaluation efforts. And here the idea was to do that coverage part. Like, let's try to add more languages. Let's try to add more linguistic phenomena. Let's try to just evaluate on as many languages as we can and see what the performance of the latest models is on these kinds of languages, what the gap is, which languages it does well in, which languages it does poorly in, and so on. So that I've considered as sort of the first phase of our work that we did a couple of years ago. After that, as we were doing evaluation of LLM kind of models, we realized that evaluation itself has become a field of study, and that itself needs to improve, right? How to do evaluation itself needs to improve, and this is actually the work that we did on contamination, on LLM judges, and so on. And so how to make that evaluation process rigorous was the sort of the focus of our work for some more time. After that, we really looked at, yes, we have this Hindi data set, we have this Odia data set and so on, but is it really representative or not, as I was mentioning, right? And so we started this stream called community evaluations, where we try to involve just regular people from these different parts of the country in the evaluation process. And I'll talk a little bit about that later. And then finally, since the last year or so, we have also been looking beyond accuracy. So not just in terms of how well the model is doing, but also in terms of other dimensions like safety, bias on certain social dimensions, and so on. So that is the work that we've been doing since then as well. The one of the newest efforts that we are doing is actually creating a new multilingual, multicultural, multimodal safety benchmark with a few other partners, few other countries around the world as well, which will be out in a few months' time. Okay. So now I'm just going to give some highlights from some of these projects in these different buckets, just to give you an idea of how the work has evolved. So I'll quickly talk about the mega work, which was really the big evaluation benchmarking work that we did. So here the research question, and this was just after ChatGPT came out, was how well do these LLMs perform on non-English languages, right? So different languages, different model sizes, open versus closed models on different kinds of tasks, data sets, and so on. And we did a very large scale evaluation on multiple languages, multiple tasks. So going from classification to generation, sequence labeling, question answering, even some visual benchmarks as well, and a couple of small responsible AI kind of tasks as well. And we had some other things also, which I'll not go into. But basically, this was the setup at that time. And this looks very simple now that we've become very mature in terms of prompting and so on. But we try to design different kinds of prompting settings for how to do this kind of evaluation. So, what should the language be of the instruction that you're giving? You're saying you are an NLP assistant, you need to decide whether you need to solve this natural language inference problem and so on. Then if we want to give few short examples, that is examples for it to learn from, then in the prompt itself, then how do you give that? What is the language that that should be in, etc. How should the test example look? Should we translate this? Should we not translate this? And so on. So there were a lot of design choices that we made. And at that time, of course, the prompts were very simple. We also had very little tokens at that time to play with. And so we came up with simple prompts, but we found a lot of differences in the way we designed these, different components of the prompt. They actually made a difference in the final outcome. And at that time, the models were much more sensitive to prompting than they are today also. So we actually found that that was the case. So at that time, the result that we found initially was that some of the older models actually, so if you remember like the BERT models and so on at that time before LLM, if you fine tune those models on some of these tasks, they actually performed better than LLMs, right? So there was actually a gap between the fine tuned models and the LLMs at that time initially. And the smaller models at that time, like Mistral, Llama, and all, were very poor. Like they performed really badly. Even some of the models that were specifically created for multilingual, for different languages, like Bloomsy, that also performed much poorer than expected. And this was at the very beginning. However, what happened was as time went on, the LLMs actually started doing better than the pre-trained models, the sequence to sequence models, and so on. And soon, even the smaller models caught up. So even the Mistrals and the Llamas and all that became much better at different languages. We also did this study in Mega where we tried to see, is it better to just translate everything to English and then to query to give the task to ChatGPT to do in English, and then ChatGPT or whatever the LLM is will give you the response back in English, and then you translate it into your whatever the target language is, right? Is it better to do that, or is it better to directly prompt the model in the target language itself, right? And we found that for some languages it is actually better to do this translation into English and then prompt in English and then get back the result and so on. And for some other languages it is better to just directly prompt. So all the languages where the bar is above the zero, that is all, those are all the languages where it is better to do the translation, whereas the other languages are the ones where it is better to just directly prompt in the language. So you can see that for Japanese, Korean, Turkish, Swahili, Chinese, Spanish, French, and all these are the high resource languages. For these, it's better to just directly prompt the model. Whereas for many of these other languages, it's much better to do the translation because the model itself is not capable in that language, right? So our large scale evaluation revealed these kinds of insights also, right? So if you're building an application, then you know whether to do this translation or whether you can directly just go and prompt in that language itself. Things have changed quite a bit. Like this was, 3, 4 years ago. So as you know, the pace of change is very fast. So now I think this, if we redid this experiment, this chart would look very different. And I won't go into this, but we also found that, for some language families and some scripts, the results were much better. And for some of the other scripts, the results were much worse. So for example, we found that for the Indo-European languages, typically we found the best results, whereas some of the other language families, the models were doing poorly overall. Same way for script, we found that for Latin script, actually the models were doing well across most of the data sets, whereas for other scripts, models were doing much worse. And one of the things that I already mentioned was tokenization. So we found that the for fertility of the tokenizer, that is how well the tokenizer is able to break up the words into multiple units. That is a very big correlator of the performance of that model on that particular language. So we plotted basically the fertility of the tokenizer against the accuracy or the score on that particular language, and we found that there's a negative correlation there. So the better it is at tokenization, the better the performance is, or the worse the tokenizer fertility, the better the worse the tokenizer fertility, the better the model. So this is a clear signal that shows that doing evaluation actually tells you about the what is going on within the model, right? So by doing this kind of evaluation, by knowing that tokenization is correlated, it's not causal, of course, but it is correlated with the performance. You now know that if you want to actually improve the model, one of the places that you can focus is on building on improving the tokenizer itself, right? And that is what happened. So over the next year or two, there was a lot of focus on making sure that the tokenizer is better. It's still not equally good across all the languages, but it's at least not got the gaps that we used to see earlier at that time. And so tokenizers have got better. Model performance has also become much better now for many of the languages. So I'll just end with this, that the key takeaways from this large scale analysis that we did was basically we found initially that there was a large gap between English and other languages, especially for low resource and non-Latin script languages. At that time, also open models were generally worse than closed one. I think this is still true to a large extent. That the open models are are much worse at multilingual compared to the closed ones. Also, although there are some exceptions, especially the Chinese open models are very good. Poor tokenization, as I said, is correlated with poor performance, but this has improved drastically in the last couple of years. And this contamination problem, that is the problem of the benchmark already being there in the model, that creates a lot of problems in interpreting the evaluation results, because you don't know whether the evaluation results are the way they are because the model has already seen the data set, or because the model is genuinely capable of that performance in that particular data set. And so any kind of evaluation that is done is meaningless without doing this contamination check, because only when you can prove that the benchmark is valid for the evaluation that you're doing, only then you can take the evaluation result seriously, right? So if anybody gives any kind of benchmark numbers without also showing that that benchmark has not already been consumed in the model itself, then it is always a red flag. Okay, now I'm going to quickly go over this in just 2 minutes, and then I want to go to the next part, which is the community evaluation part. As I already mentioned, the LLM judges have become a very popular way of doing model evaluation, where you can prompt the model. So this is one example of a LLM judge prompt, where the LLM judge is being asked to check for linguistic acceptability. So linguistic acceptability is basically, does this sound correct to a native speaker of that language or not? And so there's a rubric that is given of 0, 1, 2 score, and it is being told like, okay, 0 score means that the sentence is not it has incorrect structure, it has some incorrect words, or word choices are not okay, so then give it a score of 0. Give a score of 1 if it is in between, and give it a score of 2 if it is very good, right? So this is the kind of prompt that is given to the LLM, and so it becomes an LLM judge. And now if you give it a new data point and say, okay, what is the score on this data point, then it will give you a score of 0, 1, 2. So this is the simple LLM judge setup, and this is used a lot. Like, it is used everywhere, especially in industry. It is used very, very heavily to do all kinds of judgments. And here you can give any rubric, right? You can give any metric to it and say that, okay, this is what 0 means, this is what 1 means, or this is what 0 to 100 is, and any kind of range you can give it, and it will give you some response, right? And the thing is, though, that it is meaningless to use LLM judges unless they actually agree with what a human judge would say, or any other metric that you have of interest, which you're trying to optimize for, which you're trying to replace basically with the LLM judge, right? And so that really needs to be checked before using LLM judges to do evaluation. We need to ensure that they actually agree with whatever human judges or whatever else we are replacing, right? And so the question is, right, that if the LLM judge paradigm actually works, then it's really great, because you can then scale up evaluation very quickly. You can judge any language, any data, any kind of metric, any kind of rubric. You can specify. There's a lot of flexibility because you can prompt it any way you want, right? So you can actually scale up the problem. You can cover more languages. You can make everything very localized, etc., etc., right? But does it actually agree with what humans say? Like, is it actually valid? Is it actually giving us things that make sense, or is it giving some random responses or not? So that has to be checked very carefully, right? So the thing is, like, how, first of all, how should we create these prompts? Like this particular prompt that I'm showing you has been created after a lot of trial and error, right? So how should we create the prompt for the LLM judge? Does the judgment actually agree with human judges or not? And does it vary by language, model, task, etc., right? So is it that the LLM judge works well in English but does not work well in other languages? And that is essentially what we found, so we found that, I'll just talk about this particular one. We found that LLM judges perform much worse on low resource languages and also non-Latin script languages compared to English, right? So it may be standard that yes, we can use LLM judge for this particular English task, but if we assume that just because the LLM judge works well in English and use it for multilingual settings, then we may get into trouble because it may actually have very poor agreement with humans. And this is because the LLM itself works poorly in other languages compared to English, right? So it's expected to work poorly as a judge also compared to English. One more thing that we did is, we can also ask the LLM judge for an explanation. Like when it is making a judgment, like if it gives that score of 1, 2, or 3, right? Or 0, 1, 2, you can ask, okay, why did you give the score of 0? And it will give some explanation, right? And so we did a lot of studies where we gave the same task to LLM judge and the same task to human and also multiple humans. And then we checked what is the agreement between the human and the LLM, of course, but we also checked for the explanations. So we asked the humans also to give explanations when they were rating something 0, 1, or 2, like why did you give a 0, why did you give 1, why did you give 2? And we got the same explanations also from the LLM judge as well. And then we compared and saw, we did like qualitative analysis and saw whether there's any agreement or not. And we find that a lot of times the LLM judge explanation makes no sense at all. Like it is just very random. So that also cannot be trusted, right? Just because it is explaining this is how I did it doesn't mean that that is valid or that is actually correct. And so if anyone is using, like, the main takeaway from this LLM judges, if you are using LLM judges in your workflows, you have to be very, very, very careful because there are chances that you will get numbers, you will get explanations, but they may actually have nothing to do with the reality. And it may hallucinate, it may do all sorts of things. And so there have to be checks and balances at every stage, and there always needs to be some human oversight to make sure that at least a subset of whatever the LLM judge is doing should be done by humans, so that you can always keep checking, making sure that there is reasonable agreement between the humans and the LLMs. So just to summarize this particular part, LLM judges show bias in different ways. Like we have found that they have all sorts of, if the answer looks a certain way, even if the answer is incorrect, the LLM judge will give higher scores to it and so on. And, the essentially the problem is that LLM judges are being used everywhere and with very little caution. And so what we are advocating for is, we are not saying don't use LLM judges because they are a very useful tool and they really help speed up things. But when you're using, use very, very carefully. Right? So last thing I'll try to cover in another 5 minutes or so is our work on community evaluations. And this is to try and really, democratize the process of evaluation, right? So we started by asking this question: who evaluates models, right? Who is actually deciding what should be evaluated? Who is creating the benchmark, right? Second is, who decides what a good response looks like or what good looks like? So when I showed you that rubric of 0, 1, 2, that's basically a very standard linguistic acceptability kind of rubric, right? But if you're looking at a more culturally nuanced setting, right, where you're checking for something else, right, then who is going to determine what 0 means, what 1 means, what 2 means, etc., right? We don't know. It's usually somebody in the lab who sits and does it, right? Who does the actual scoring or grading of a model response? Is it done by LLM judge? Is it done by a human? Who is the human who is doing that? And is there a way to involve community? So that is just the regular lay people in this process, because they are the ones who are most likely to be affected by many of these models and systems that are going to be out there. So that was the philosophy behind the community evaluations work. And this we did in two parts. Like last year, we did something called Pariksha, last year actually. And then last year and this year, we've been working on something called Samiksha, where this is in collaboration with an organization called Karya, which many of you may be aware of, which is an ethical data company, which tries to bring data work to rural people so that they have a source of income. And this is all ethical data work. They are paid several times the minimum wage in India and so on to make sure that they're getting fair wages for the data work that they're doing. And typically, they end up doing data work in their own languages. And so what we decided was, let's try to get them involved in the evaluation process also. Instead of just getting, data work like getting speech recordings and so on, like they will also do evaluation for us, and they will decide whether a model is working for their language, for their culture, etc. or not, right? So this was very challenging, of course, because this set of data workers had not done evaluation. Many of them had not interacted with a GenAI system, so they didn't really know what it means to evaluate the output of an LLM, right? So we had to do quite a lot of training and so on to help them understand what they are looking at, how they should be doing the evaluation and so on. And this we actually launched, the Samiksha report we launched at the summit this year. So this is what the interface looks like for them to do evaluation. So on the right side, this is basically they do it on their phone, and this is basically a question in Kannada, and there are two responses, and their task is to mark which response is better, or if both of them are equally good, then they can also check. They can also mark it as a tie, right? So this was one of the tasks. We did different kinds of evaluations with them, but we ended up doing this, both in for Pariksha and Samiksha. We did this across many different languages, many data points, and so on. So this is the sort of the leaderboard from Pariksha. You can look at this in more detail. We have an EMNLP paper on this, but this is basically showing the results on many different languages, 30 different models that we did with these Karya workers. We did more than 1 lakh evaluations with them to come up with this kind of a leaderboard for different models. And on the left side, you can see the leaderboard for the human evaluator, that is the Karya workers. And we did the same evaluations with LLM judges as well, again, to see what is the sort of difference between humans and LLM judges. Overall, the trends are similar. So the orange dot, which you see, right, that is at that time, GPT-4o was the most best model in 2024 for multilingual. And so that is what it shows at that time. Last year, we started this other project called Samiksha, where we wanted to involve even more people, not just the data workers to do the evaluation, but even what is evaluated, what the rubrics look like, etc. We wanted to involve the community even more. And so we did a much more detailed sort of pipeline. So this basically comes in three parts, where the first part of it is just to understand what a benchmark should comprise of. And for this, we work with various civil society organizations in different domains. So here it is not a general domain benchmark, but it is focusing on these four domains that we think are important in India. One is healthcare, then finance, education, and legal. And these are not the questions that a technical person would ask, like it's not something that a lawyer would ask, but these are the kind of questions that a regular person would be asking if they wanted legal advice. So, for example, they have some land and there's some land dispute or something like that, then they may want to go and ask a LLM for advice. And so we want to try and build a benchmark like that. And so we work with all these civil society organizations that work in these different domains to try and decide how this benchmark should look, what should be the questions that are in the benchmark, what should be the rubrics that we use to evaluate the responses on these kinds of questions, and so on. And that was the first phase of the pipeline. The second phase is to create the actual data points that will be there in this benchmark, right? And so this was done by the data workers, so the Karya workers. So we used the insight that we got working with the civil society organizations, and we created training material from these different insights. And these were given to the Karya workers to then create individual data points. And we did this independently in each of the 11 languages that are shown here. So no translating from English or even from Hindi to other languages. For each language, the Karya worker who was a native speaker of that language would take the training material that was given in the previous phase, and then in that domain for their language, in their cultural context, they would create a data point. And I'll show a couple of examples of data points also. So we created a data set, a benchmark data set of 23,000 points using this process in the second phase. And then the final phase is, once we have the questions and the rubrics to evaluate the answers, we have to then get responses from different models. So we did 17 different LLMs. we got responses for this entire benchmark, and we did again evaluations with the Karya workers on which answer is better or scoring a particular answer. And we also did LLM judge evaluation. So 1.5 lakh evaluations with the Karya workers and 16 lakh LLM judge. So this gave us tons and tons of data to look at, to analyze, like which languages are getting low scores, which domains are getting low scores, which kinds of data points the models are all failing on, or is there a difference between the different models, etc., etc. So we have some very, very, very comprehensive leaderboards also on the Samiksha website, but I'll give you a few examples of some of the data points that we have. So the example here is in the original language, and we have just provided a translation here to make it easy to understand what the example is talking about. So this particular question is asking, about something around career guidance, and the response, there were multiple responses from multiple models that were scored by Karya workers who speak this language. And we did a lot of qualitative analysis to see that some of the low scoring responses were just not relevant to Indian context. So some of them talked about internship and industry visit and psychometric assessment and things like that. And the Karya worker who was evaluating this felt like, this is just not, in my context, this doesn't make any sense, like this kind of response, right? Whereas there was this other question, I think this is in Marathi, where this was about, how to choose a school for my child or something like that, right? And here, in fact, the Karya workers who were evaluating this particular response from a model thought that this is a very good response because, it talks about different dimensions that were important for them. It also talked about some actionable advice for them, like you should go and visit the school and so on. So they actually connected with that answer much more compared to the previous example where they just couldn't connect with that answer, right? So the point of this benchmark is to really take, to understand these aspects, right? Are people able to connect with the response from Gen AI systems in their own language, in their own culture, or do they feel like it is very westernized, very alien to them, etc.? So that is what we are trying to measure with this whole evaluation process. Another example which was quite surprising to us is we had, of course, Bangla queries, right? And we had not specified the country when we gave the question, right? So it's okay if the model assumes Bangladesh, right? Because we are not giving any we are not saying that this is from West Bengal or this is from India. So we are just giving a question and it is giving a response, right? But we found that in some of the responses, actually, the model started confusing Indian and Bangladeshi jurisdictions while giving the answer. So in this case, it is about, some consumer court thing. And so in the first half of the answer, it talks about, Bangladeshi consumer court. And then at the second half of the answer, it starts talking about Indian, like some complaint number or some such thing like that, right? And so the Karya worker did not like this at all. They were like, what is this? It's actually confusing between, India and Bangladesh. At least it should be consistent within one country's jurisdiction when it's answering like this kind of legal kind of query, right? One more example here is about somebody who wants to build, who wanted to buy a house. And so they're talking about what precautions, and this is again in Marathi, where one of the answers from one of the LLMs was scored very high. And the reason is because it took into account a lot of the concerns that Indians would have in buying a new house, a lot of the local frauds and risks, illegal transactions, etc., that may be happening. And because it was a Marathi question, it also referenced some of the Maharashtra local laws also around this, right? So the Karya worker was very happy with this and said that, oh, this actually knows about my own context in Maharashtra, right? And it is using that in order to give the response. So this got again a very high score, right? So overall, like the key findings of this is that we checked these models on different dimensions, which I didn't go into, but we checked them from different angles, and they're good now at responding in these languages. They don't make too many mistakes. Language quality is good. But this cultural relevance, local relevance, that is still a differentiator between the best models that perform very well versus some of the other models that don't perform so well. Among the domains that we studied, healthcare actually is the most challenging. Many of the answers in the healthcare domain were marked as very bad responses or not appropriate responses at all. And so, given how important healthcare is and how much it, how critical it is as a domain, we really need to ensure that our models are better, because we know that people are asking healthcare related queries to LLMs, right? I think all of us have, either we do it ourselves or we know people in our families who are actually asking ChatGPT about their healthcare queries, right? And we find that this is a domain where models are not doing well yet. Models still make some errors, like they make grammatical errors, they use language awkwardly, sometimes they mix languages also awkwardly. But I think the bigger problem here is that they sometimes they give very impractical suggestions that do not fit the Indian context, right? Or may fit only a very urban kind of context and may not be relevant to the rest of the country. That is a more important thing to sort of address. And we also, of course, did the LLM judge evaluations in addition to the human. And because we did the same ones, we could compare human and LLM here. And again, we really advocate for using LLM judges very, very carefully, because there are a lot of gaps between how humans evaluate versus how LLMs evaluate, especially in low resource settings. Okay, so just to conclude here, so where are we at, and sort of what is the way forward? So I spoke about coverage in terms of multilingual evaluation. So, we have around 100 languages that model support, but evaluation is still lagging behind. We're still only evaluating on a small subset of those 100, and we are barely doing dialects and code switching and things like that. Safety is also a very big missing sort of piece. In terms of representativeness, many of these data sets are still very Western centric. Many people still do this translation, and we have low coverage of more realistic tasks that we will actually use these AI systems for. And trust is a very big issue because of the fact that as soon as you put the benchmark on the internet, it is going to be scraped by the next model. And then it's no longer valid as an evaluation instrument after that. And I think there's also this problem that Professor Rao, whom many of you may know, right, he keeps alluding to, is that we have a lack of scientific skepticism when we look at results now, right? So if a new model comes and it claims to do like 95% on some benchmark, and we just take it and we don't question it, I think, given how many problems I showed you, all the criticisms of AI evaluation, so many papers and so many reports, right? Given that there are all these issues with evaluation, we should not take it at face value unless we are convinced that it is being done in a rigorous way, it is being done in a way that there is no contamination, that whatever the benchmark is claiming to measure, it is actually a valid instrument in order to measure that, etc. That kind of, I think, skepticism we need to have in order to make sure that we are not getting caught up in any hype, right? When we are looking at results from, whether it is results in a conference paper or whether it's a new model that has come out, wherever it is, I think we should look at the evaluation very carefully to make sure that it is not falling into any of these traps and claiming something that is not true. So finally, what the future work, I think, would look like. I showed you this diagram of the 4 stages. I think model evaluation, everyone is paying attention to. Product evaluation also to a certain extent. User evaluation, I think, is very lacking still. We are not going and doing those field studies which will tell us whether these interventions are actually, giving us the outcomes we need. Same thing for impact evaluation as well. And we need to really expand our field and learn from some of the, sort of the adjacent fields that have been doing some of the other kinds of evaluation and bring in some of that rigor. But I think we also need to involve some of the other interdisciplinary folks into our own field as well, so that our field also sort of expands and improves in terms of claims and validity and so on. So yeah, I will end with that, and happy to take any questions. Please feel free to ask.
Yes, any questions from audience side? You can unmute yourself and ask the question.
Hello, ma'am.
Yes.
Yes.
I'm Abhisho from Nepal. My supervisor, Professor Suresh Manandar, is a close friend of your supervisor, Professor Ellen Black at CMU. I would like to ask a few research questions regarding low resource code switch speech recognition, especially for Nepali English data. First question is, how can we effectively create mixed code data for low resource language such as Nepali English? Are there any recommendation strategy for synthetic data generation, linguistic consent, or prompt-based approaches? My next question is what are your thoughts on post-training approach for mitigating catastrophic forgetting? Uh, from my understanding, PEP-based method don't fully solve the
Yeah.
forgetting problem. Similarly, technique like regularization as elastic weight consolidation
Yeah.
regulation also seem to have limitation, especially because feature information can overlap when trying to preserve knowledge across multiple domain or language. Uh, Next question is my in case of the evaluation, there is no benchmark dataset available for Nepali English code switch ASR.
Mhm.
What would be good approach for creating reliable evaluation benchmark for code switch speech recognition? Thank you.
Okay, great. All three questions are very good, I think. So the first question on creating code mixed data in Nepali English code mix. So I think there are many approaches that one can take. So there have been linguistic theories, of course. There are tools that try to implement those theories, so you can use those and try to generate data. Um, Not all of those may be valid, so you may also want to do a check after that to make sure that the data that gets generated is valid. One way people do is just prompt an LLM and it will generate something, but that is, you need a check on that. Like you need to see whether that actually um, follows the linguistic constraints or not. So you can do it either way, like either generate with linguistic constraints or generate with LLM and then sort of filter out the ones that don't match the linguistic constraints and keep the ones that do, right? But all of this, even if you do, right, it's not just about the linguistic constraints. I think it's also about how people sometimes, even if it is linguistically correct, it may not be perceived as natural by native speakers. So the native speaker has to be there in the loop somewhere to check whether the sentences are sounding natural or not. And so if you're of course trying to generate a large amount of data, you may not be able to get every single sentence checked, but at least some proportion of it should get checked by native speakers. So native speaker has to be there in the loop somewhere, but I think there are multiple ways of now generating this kind of code mix data if you want to go the synthetic route, right? If you want to go the natural data route, then you have to find sources where this naturally occurs, right? If there are any discussion forums, or if there is any source of data where people naturally speak in this way in terms of text, then you can try to collect the data from there. Or it may be easier to collect spoken data in this form, and then sort of convert that into text if text is what you're looking for, right? So that's the first part about code switching. And let me just talk about the ASR, the third question as well, which is how do you create a benchmark? And I think benchmark creation has to be very carefully done, because ultimately the evaluation is being done on that benchmark. And so whatever you're claiming is on that. So that data creation, I would be very careful. So I wouldn't do that, just sort of anyway, since it is for ASR, you need speech data. So I would suggest, actually, instead of just trying to collect code mixed speech data, you tie it to a particular domain or a particular use case, right? If there is a place where people are already um, using an app, or speaking into an app or something like that, and if you can somehow capture that, I think that becomes a better sort of way of collecting natural data, rather than telling people to speak and then they try to speak in code mixed ways. Although that can also be done, like you can get people to have conversations with each other about topics where they're likely to do code switching. So maybe more personal topics about their family, about their lifestyle, about their home, village, something like that, where they're likely to mix more compared to, say, very formal professional kind of topics where they may stick to English, right? So I think those kinds of approaches you can use to collect some realistic data, and then get the transcripts created by native speakers, and then use that. The more realistic or the more tied to a domain, the better, the more representative it is likely to be. So whatever evaluation you do on that is more likely to be representative of how it will be in the real world as well. For the second question about forgetting, I think this is a very big concern. We've done some work recently on this, where if you fine tune models, then they tend to forget things that they knew during, before fine tuning, right? And that is the catastrophic forgetting problem. And this happens in multilingual. One concern is that we find over and over again is sometimes if you do only multilingual fine tuning, English performance starts dropping, which is usually not desirable, because you will find English used, right? Even if you have a multilingual use case, there will be some English, so you don't want the English to drop. And so people have tried doing various things where they try to, there are these standard continual learning kind of approaches like generative replay and layer freezing and things like that, which people do, where they try to make sure that some part of the model at least remains untouched while the rest of it would. PEFT also should do that because it's not touching the entire models, right? It is only touching like part of it. But even with PEFT, we have found that forgetting happens. So one of the things that we don't do well is we don't do this evaluation also of forgetting very well, right? We don't even know what it has forgotten and what is remaining, because we don't have a good benchmark also to measure that. So there also I feel like evaluation plays a very critical role, where even knowing what the model is keeping and learning and what is forgetting is also not very clear. So, I mean, to sum up, I would say that I think there are some techniques, standard techniques to do in order to make sure that that forgetting does not happen too much on whatever you are trying to you're trying to preserve, right? You're trying to preserve it even in the after the fine tuning. Having said that, like overall, I think fine tuning is very tricky. Like you have to have that the data that you're using for fine tuning is very, very critical, because if that data does not contain what you want to do with finally with your application, then I think you're in trouble, because it will not know, it will forget other things, the model.
Okay, ma'am, thank you.
Welcome.
Any other questions?
Yes, sir, from my side.
Yes.
Hello, ma'am. Thank you so much for
Hi.
such an enriching presentation. Ma'am, my question is a bit out of context but relevant. Ma'am, when we go for benchmarking some sensitive data such as women abusement, women harassment, child abusement, then what you have told initially, the data gap, model gap, evaluate gap, everything is there. So, what is your valuable suggestion input towards this benchmarking such sensitive data? That multilingual Indic languages, particularly because AI safety checks already passes this. It will simply hold on.
So if the data is free from any personally identifiable information about the person, right, then it can still be used with the consent of the user who is contributing that data. Then I think it's a very valuable data set, because it tells you about all these kinds of harms that otherwise may not surface in any of these safety benchmarks, right? So if that kind of data is available and people are willing to share that kind of data, of course, with
Yes,
all
ma'am.
privacy.
I have almost scrapped from the Reddit, and it's regarding women abortion, domestic violence, cyber abuse. Everything data has been collected. Now the question is, do I need for copywriting something? Means getting, actually, suppose the papers like AAA and all, they need certain. What I say, copyright from ministry permission should be there. Is it so? What is your experience?
Yeah, so it depends on, if it's from Reddit, it depends on the terms of use of Reddit. So it depends on where you're scraping it from. They will have some terms of use on what you can do with their data and what you can't do, right? So you will have to look at that. I don't know what it is for Reddit, but you'll have to look at that and see. Some of them allow you to use their data for research purposes as long as the data is free from any personally identifiable information. So any information that you feel can identify someone, right, even by their username, not their real name, of course, may not be there. That can be removed from the data.
That
it can be
pre-processed,
anonymized, pre-processed. And after that, if the Reddit terms of use allow to publish the data or use the data for research use, then it's fine, I think, to use that kind of data. So you have to just check what the usage guidelines are of that particular platform for research and other use.
Yes, ma'am. And last point you told about contamination check. So for such sensitivity data benchmarking for this task, how contamination checking will be done? That impact evaluation I really want to put.
Yeah, so I mean, contamination here, it would be partially contaminated into the model, because all the models would have seen Reddit, right? So all of them would have consumed the whole public Reddit data that is there. But if you're creating a benchmark out of this, right? So if you're labeling something, if you're annotating something from this, that data, if it is kept private, right? If you don't put it on GitHub for the model to just scrape and get the labels also, then it's fine. Then it's not going to be contaminated. If you put the labels also on the internet, then it's very likely that in the next pass of scraping, all of them will get into the models. Then you won't be able to use it for evaluation anymore, right? Or if you use it also, you may not get the appropriate results out of it, right? So but I think if you do annotations, etc., I would urge you to keep the annotations in a format that cannot be easily scraped by the model. So you can keep it as a password protected thing, or even if you want to put it online for people to use, right? You can
Yes,
have
ma'am.
them
I want to make
do
it
something.
explainable framework also.
Yeah. So something like that you can try to do when you create a benchmark out of it. But otherwise, I think if you can do some annotations on top of this, then, and if you find that models are not able to respond properly to these kinds of queries, etc., then that's a very useful benchmark to create.
Yes, ma'am. Thank you so much.
Any other queries? Yes, any other queries are there? Okay, ma'am, thank you very much.
Thank you so much.
I'll be in touch with you.
Yes.
Okay, I'll talk with you later. So thank you very much.
Thank you, everybody. Bye-bye.